Today we are going to be talking about different pairs of angles. So yesterday, if we remember, when we talked about the angle addition postulate, those angles were right next to each other. And we talked about the fact that they shared a common side. And so they looked a lot like this. We could definitely add angle 5 plus angle 6 to equal that whole straight angle. And so they have a common side. When two angles have a common vertex and side, right? So it looks like this one, then those are adjacent angles. Adjacent angles are next to each other. These are not, right? These are not because they're not touching, right? They don't have a common vertex or a common side. Next, complementary and supplementary angles. Here's how I think you can remember. Well, first of all, complementary angles are angles two angles who have a sum of 90 degrees. So they can be next to each other like this one, or they don't have to be next to each other like that one. So we can see in the first picture, angle 1 plus angle 2 together using our angle addition postulate will make 90 degrees. In the second one, we can look at 70 plus 20 equals 90. So they're complementary as well. And each angle is the complement of the other. And so, again, they don't have to be next to each other. So complementary is 90 degrees. Now, supplementary is similar, but they have a sum of 180 degrees. So we can see here, using our angle addition postulate, they make a straight angle together, so that's 180 degrees. So angles 3 and angle 4 are supplementary. And in this other picture, if we did 115 plus 65, that equals 180. So again, they don't have to be next to each other, but they just have to be two angles that add up to 180 degrees. Sometimes it looks like it in the picture, or else we check the addition. And so we say things like angle 3 is supplementary to angle 4, or angle 3 is the supplement of angle 4. Now, how I'm going to help you remember this. So C is 90. Notice S. S is kind of like two C's. Do you see that? S is two C's. So two 90s is 180. So I don't know. I'm just trying here. So if that helps you, great. Okay, so we're going to name a pair of adjacent angles, a pair of complementary angles, and a pair of supplementary angles. All right, so let's do this. First of all, these two angles here are next to each other. You see that? They have a common vertex and a common side. So we're going to get to practice naming angles. So we would say angle CAB and angle DAC are adjacent. Okay, so that's one answer. Next answer, we need complementary angles, two angles that add up to 90. Well, the only possibilities are these two, because that one is already too big, right? So let's check that. 37 plus 53. Oh, yeah, they do add up to 90. So we can say angle CAB and angle R. Oops, I said R but wrote S. RST are complementary. Okay, so that's one. And then the last one is we need supplementary. So I don't think that 127, the 7 and 7 isn't going to equal 0. So I know that's not right. So it's probably these two right here, right? Those two could add up to 180. So let's check. 127 plus 53 is 180. So angle CAD and angle R, oh my gosh, I keep doing that, RST are, supplementary. If you want to abbreviate, you could say SUPPL, or here you could say COM, complementary. Okay, you could say that. We can abbreviate a little bit. Okay, so we've identified adjacent, complementary, and supplementary angles. Let's now use what we know to find some missing measures. So find the measures of angle 2 and angle 3. So we can see angles 1 and 2 equal 90 degrees, right? This whole thing is 90 degrees. So it's kind of like angle addition postulate. So we know that 62, we'll call this x, right? I don't want to say 2 because then it's going to look like a number. So 62 plus x equals 90. So we're going to subtract 62 from both sides, and we get x equals 28. So x, or in other words, equals the measure of angle 2. Okay, so 28 equals the measure of angle 2. We'll call this one y, just to distinguish between the two problems. So here we know this whole thing is 180. So 47 plus y equals 180. Subtracting 47 from both sides, we get y equals 133. So 133 degrees is equal to angle 3. Okay, so, I'm just looking at what we have to do today. Okay, so angle 1 is a complement of angle 2. So if you want to give yourself a picture, you know complementary means 90 degrees. Okay, and so that means that angle 1 and angle 2 equal 90 degrees. So sometimes that helps people to have a picture. So angle 2 is 5 degrees. What's angle 1? So x plus 5 equals 90. X equals 85 degrees. Now, obviously, I didn't know, which is the measure of angle 1. I didn't know what the answer was going to be, so I just made a picture that showed two angles that equal 90. But obviously, it's not drawn to scale because it would probably look more like this. That angle 2 would be a little sliver, and this would be 85, and that would be 5 degrees. Okay, angle 3 is a supplement of angle 4. So, oops, again, if you want to have a picture, two angles that are supplementary. So two angles that equal 180. It says angle 3, and this will be angle 4, because angle 3 is 148 degrees. So that would match that one. We'll call this y here. So 148 plus y equals 180, minus 148, minus 148. Angle y equals 130, oh, not 132, just 32 degrees, just kidding. 32 degrees, which is the measure of angle 4. Okay, so we've got complementary angles that add up to 90, supplementary angles that add up to 180. And here's the last pair. So linear pairs. So I just drew these supplementary angles up here. They're actually a linear pair. So notice in the word linear, there's the word line. So it's if two angles are adjacent next to each other and they form a line, right? If two angles form a line that are next to each other, then they're called a linear pair. So they are also supplementary, but when we define supplementary, they could be like this too, right? They could be next to each other. We just said they had to add to 180. But when they look like this and when they're next to each other and form a straight line, then they're a linear pair. So they're a pair of angles, two angles that form a line basically. Finally, we have vertical angles, and we use these a lot. So vertical angles are opposite from each other in the x. So angles 4 and 5 are vertical angles, and angles 3 and 6 are vertical angles. So it's vertical angles are when you have the x. And when angles are opposite on the x, they're called vertical angles. You can kind of tell from the picture, they are also congruent. And so with my special markings, I'm indicating that. So angle 4 and 5 are congruent. We're not really emphasizing that now, but might as well mention it. And angles 3 and 6 are congruent and vertical. All right, identify all the linear pairs that include angle 1. So here's angle 1. Okay, what angle is next to angle 1 and forms a line? Well, one of them is angle 2, right? Angle 1 and angle 2 form a line. So angle 1 and angle 2 form a linear pair. And also angle 1 and, let's look at this one here. Angle 4, see how those form a line? Sometimes you don't see that as much when it's not straight across, but angle 4 also forms a linear pair with angle 1. Next, identify all the vertical angles. Oh my goodness. So we look at this x here, right? Here's one x, here's another x. So here it's pretty straightforward. So we could say angle 1 and angle 3. See how they're opposite across from each other on the x? Angle 2 and angle 4. All right, so that takes care of that x. Now let's go down to the other x. So here, the second one is a little more complicated. So let's look at this one and this one. And this is a little bit challenging. I will give you that. So it's vertical angles. So it's just a pair of angles. So can you see like 5 and 8? Angle 5 and angle 8 are across from each other on the x. And, you know, we're not looking at this and this because it's not one angle and another angle, but it's a pair of angles and a pair of angles. So that's no good. So we're going to cross all that out. And now let's think about what would be another x here. So what if we did this x, this one, and this one? So similar, see how these two are just single angles across from each other? So we could say angle 6 and angle 9. So we can see that one. And then finally, we can, I forget which ones I did. Okay, here we go. So finally we have right here and right here, angle 10 and angle 7. So if you can just look at this picture on the right and see, oh, yeah, I can see these two have the same two sides and are across from each other on the x. These two have the same two sides and are across from each other on the x. And these two have the same two sides and are across from each other on the x. You don't, but I think like it helps to highlight to see, because sometimes with all those extra lines, it's a little bit difficult to notice. Okay, and let's see, are 6 and 7 a linear pair? So 6 and 7 together look like this. So 6 and 7 are adjacent angles. They're next to each other, but they don't form a linear pair. No, they do not add to 180 degrees. Or we could say, or they don't form a line together. Something like that. So together they have to form a line, and they don't do that. And that's it.